Yoink. Announcements. Red circle. Yeah, red circle. Live on YouTube. Probably. Where's my video URL? Copy video URL. Boom. I'm gonna have to update my save the video details. Cool. It's been a good touch of time since I streamed, and I've been doing a lot in the meantime. Like a lot. We've gone from leaving you guys off seeing me read some tokens in, and not even all the tokens, to I've gotten through, for a handful of things, SEMA, or through semantic analysis of specifically this. And I'm working on an IR right now to get this to LLVM more goodly. I can't tell what my screen looks like yet either, so let me try 1080p. That is totally reasonable. So anybody here will just have to tell me what is going on with my voice. Let me know if I sound like shit. So where am I at? Need to start building up some things with the IR. Let me put this over here for reference. All right, so let's start writing the IR gen, I guess, and we'll figure out what needs to finish being implemented as we go. Module has dependencies. Dependencies generated as a bool. It doesn't actually store. It's a Laye module, so that's going to be in context dependencies. Yep. Okay. So what we want to do is generate an IR value for every function at the top level first. Second, we want to do struct types. We want to do types at the top level first, store those. Then we want to do functions. So step one, type generation. Two, function. Function. And then 3, bodies. So we can skip top level type generation for now. This program does not contain top level types. So for functions, count is R count. Module top level nodes. Then we have node. Node is this if top level node time is node function decal, duration of a function, then we can do a thing with it. Otherwise, we'll skip it. We want to generate a function. So Laye C value, function value, we'll call it IR function. Yes, IR function, so that we know what it actually is, will be module create function. So we need to take our IR module, create a function with it. It's going to need type information, but that's fine. Top level node location, this. Okay. So after location, we need the function name. So we'll say string as view top level node. We need to know what the name is. So string function name is going to be top node attributes foreign name count like to 0. Foreign name else the declared name. I need a better way to do that. Not a huge deal, but I need a better way to do that. So then we have IR function type is all we have left to do. ISC type function type. We don't have a way to create a type, so that's step one. One, we need to be able to create types. Two, we need a function to convert a Laye type to a function type. So static ISC type Laye node type, which I'm actually not going to implement here. I'm going to implement elsewhere. Love having fat fingers. Okay, so we'll implement a type in there. So this needs to be Laye convert type of top level node declared type. And we can search first that we haven't fucked up the type. It should be a function. Type is function. Laye type is function. Top level. And then we can do two things. Assert IR function type dot created successfully. There should be no case where we return no type. And then ISC type is function. The function type. It should have created a function type. Beautiful. Let me reopen my. Hello, my chat was not enabled. That's great. I'm making a compiler. Right now we are, hey Zedrich, we are creating the IR for the compiler, the intermediate representation of the code, as well as generating that IR from an already existing typed AST. So off stream, not archived anywhere, I've worked on the parser and the semantic analysis for this language. We've only done a handful of features, but it's enough that I can parse this source file over here. I can make the screen a touch bigger, maybe. It just gonna make it uglier. So this source file is being parsed by the compiler, and rudimentary type checking and conversion and stuff is going on. Oh, good. Yeah, I just had to reset all of my OBS stuff due to an installation thing going wrong. Another reason I haven't been streaming. Finally bothered to set it up, so I'm glad it sounds not bad. So anyway, we're going from this source code to this typed AST. So now we're going to take this typed AST, generate an IR module instead, which will be in SSA format to mirror LLVM, and then we're going to go generate LLVM and we'll have compiled code. So right now, we're getting the very basics of IR set up. I've already written some of the necessary functions, about 300 lines of types and asserts and actual code to get something started, but we're just going to write what we need and implement what's left when we get there. So at this point, we're going through our parsed module, which is just the source file as an AST. And for every function at top level, we're allocating an IR function for it so that we can then go through and populate the function bodies. We want to generate these function nodes first so that, for example, exit can refer to this exit function. If we start generating the function body for main before we've allocated exit, that's just kind of awkward because it doesn't exist. So that's step one. And we've basically done it here, aside from generating the type. Now we need to implement a converter from the semantic types of Laye to the actual types of the IR. So we're going to start by doing my usual assert far too many things. Type should not be null. Type should be a type. Node is type. And since it's a type, we don't care about the module or the context right now, but we just want to make sure it's a type. So we can switch on type kind, and then default case here, we can throw in our assert that we've missed something. We'll have to print a standard error for node find mod.start of node kind to string type kind, and debug information here. Unimplemented type. Good enough for me, plus a return null just because I'm paranoid. Great. So we want to handle function first. So let's do node type function. That's the declared type of our functions here. They'll get the return type plus all of their argument types pulled up into a declared type of their function type. So Laye type return type is going to be Laye convert type of type function return type. Step 1. Cool. Then we want a dynamic array of parameter types, which we will populate doing my should be a macro, but I don't want to do macros too much thing. We want type function parameter types less than count plus. So let's grab my node parameter type node. We'll do this sub I. Assert it's not null because I have access to it. And while we're at it, assert the return type is null because I'm a little paranoid, that's all. Why I am is a dynamic C type. That's what we want. Get a return type and our parameter types. So from here, array switch parameter types. Let's also assert this because create a parameter type here. IC parameter is convert type parameter type node. It's not null. No, it's going to be a type. That's an invariant of the IR. Then we push it. So then we can assert that we have the correct number of parameters. We didn't fuck up in here. Okay, so then we just have to create it. And I don't have a way to create the type in the API just yet. So we can say ISE type, ISE function type, for example. And it'll always be in a context. So ISE context. And a function doesn't have to be associated with a module, but it might want to be, or a type rather. A type maybe could be associated with a module, but I think we just want all of our types in context. So we don't have any like issues referencing types between modules semantically. So all types will be in a context and only in a context. So take the context. A function type needs a couple of things. We need a type, return type. We need a dynamic array of type for the parameter types. We need the calling convention and we need a linkage for the declaration, but not so we need Laye The bool is variadic. And the calling convention. I'll do the calling convention first. Calling convention. Going way the hell off the screen, so we'll format that. And that might be enough to get us going. Let's go into the IR and put it somewhere. Near the top, it's under modules, it's above those. I like to keep these in a relatively okay order. Okay, so we'll implement that here. We need a context. We need Laye C function type equals. We're going to allocate it in an arena for our types. I don't know if our context has an arena at the moment that we can allocate into, but it has an allocator. It has a string arena. So let's create a type arena for our types. Type arena for our types. Then we'll also want to see type for all types to keep track of everything. Let's come over here and see what is IR for the beginners here. Depends on how you think about it. I could explain it how I think about it, but if you're a beginner and you don't know how programming languages work, then that probably won't work. So we'll go through it kind of step by step. A compiler wants to turn this source code into machine code somehow. Maybe you don't want to go straight to machine code like you have other steps. Let me back up. Let me think for 2 seconds. High level, compilers want to transform source code into something else. That could be machine code. It could be a virtual machine bytecode. Could be a completely different programming language. What tends to make your life a little easier is doing that in small incremental steps. So usually the first IR that somebody will see is actually a syntax tree. A syntax tree is just representing each of these things as nodes in a tree. So main is one node in the tree that has children. Those children are its body. So this is one child of main. You can imagine it's a tree-like structure. 69 would be a leaf. It has no children. It only has parents. Exit is the start of a call. So the call's children would be exit itself as well as 69. So it's got 2 children, etc. It's a tree. It's a tree-like structure representing your syntax. Most people understand that pretty early on in compiler learning. That is still technically an IR, but people don't usually refer to it as such. Like, it's colloquially not an IR. It's just your basic representation of the source code. Then usually your second step is converting this AST, doing whatever process you want on it, abstract syntax tree AST, into another intermediate representation. In this case, we're doing an SSA intermediate representation. SSA means single static assignment. So it's like an infinite register machine where you can only assign to a register once. Once you've assigned to a register, that register can no longer be assigned to, only read from. So that's the kind of IR that we're doing. And you can see up here I've got some comments kind of look like declaring what the LLVM IR is going to look like for each of these functions, so I can run automated tests on these later. So I think this main function is going to turn into this LLVM IR, and it's going to say, hey, 0 register is 69, call exit, passing in the 0 register, right? We're not writing to this register, but we're reading from it. We're building up a similar IR to the LLVM IR so that we can very easily perform our own optimizations later if we want, but also very easily convert from our IR to the LLVM IR. We could go straight from our AST that our source code generated to LLVM IR if we were using the LLVM API, but I'm just generating text, and going straight from an AST to text that does not look like that AST is kind of a problem. So our compiler wants at least 2 steps, AST, then IR, before we do any code generation of like this. And the reason that we're generating LLVM is we get all of the optimizations for free. We get cross-platform support roughly for free. We still have to do some work on our end to make sure that it's all supported correctly, but LLVM covers a lot of our bases. So we're working on targeting LLVM as our primary backend until we get more work done. And then maybe we'll write our own backends that aren't LLVM. So you can see currently, this is the abstract syntax tree representation of this program after we've done type checking. So decal function is this main, second decal function is this exit. You can see their names at the end here. These blue numbers are their address in memory, so this is just the pointer representation of each of these nodes. The purple angle brackets are the character index into the file, so I can see at a glance, without having to know exactly what line and column, where they roughly are within the file. And after that is actual node information. So this is a locally declared main function, which probably should actually say export. We're going to see if my parser supports export. Well, I've introduced errors, so we'll run the previous version of the compiler. It does support export. So we're going to clear and do that again. So we can see that it's an exported function. All of the type checking has been done, so each of these sub-expressions has been inferred or deduced or forced into, depending the role of being a no return type, all because exit is no return. And since we're returning from main, everything up here also inherits no return. This type checking has succeeded. No return meaning we'll never execute past this function. There's the function type for exit, which is grabbed from the exit declaration. We can see that the compiler has inserted, I've marked them with stars if they're compiler generated, it's inserted a cast that doesn't exist to go from the literal value 69 to I32 here. I'll answer that in 2 seconds. The implicit cast is converted into this evaluated constant because we know at compile time what this value is. This literal value I actually need to go fix. It's supposed to be 69, but I'm not setting it properly, and I just don't care right now. I started this project, this one in particular, only a couple weeks ago. Beginning of December, I think, or just at the end of November, one of the two. I've been working off and on various compiler projects, some of them related to this, some of them not. So I've been wanting to build this programming language since about 2014, 2015, I think. And just in and out of projects that never saw the light of day. This is not the closest I've been, but the most confident I've been in a long while that this will become the final project. So hopefully, in the next couple of weeks, we'll have a decently supported language compiling to LLVM. Hopefully in the next couple of days, we'll have this program running, because we're already in the middle of generating IR for it, and from IR to LLVM IR is very simple. So we've just got to get all the legwork done to turn this into our IR, and we're good to go. Right. So what was so we need to create a function type. Let's go ahead and get this out of the way. We wanted to ISE function type. Boom. Needs a context. So context. Oh, we're in Laye function type. We don't want to do that. Laye function type. We need to arena push context arena type arena. Assert that exists. We then want to size of the function type itself. Assert that we got a function type, because I have actually had bugs in my allocator that return null. Since this is, I've implemented my own allocators and my own arenas, I'm a little bit more paranoid that I did it wrong. So that's why you're seeing all these excess asserts everywhere. I'm doing a lot of things kind of from scratch. So I need to guarantee that I've implemented them correctly. A little bit excessive. I don't have to do all of them, but it's good to like hit the debugger and see exactly which assert failed, rather than having to be 5 calls down the line and having to walk up the stack to figure out which one was the actual problem. Helps me in debugging. So from our function type, we need to do a couple things. Function type kind, and we could probably wrap this up really quickly into a nice internal function. So let me do that real quick. Static ISE type, ISE type 8, and all it needs is a context, type kind. Types don't need locations. They don't really need anything. So we'll just do this. So we'll grab everything that we wrote here. Context type array is fine. Type kind is kind. Return type. So now I can just say function type is type create context and type function from Laye assert function type. But no, should never be, but again, we're going to be very careful. Context should exist, and then I can return the function type. Okay, so this is a Laye type pointer, which fixes all those errors. Okay, so then what we want to do with the function type is set the return type to the return type. It also not be null. Okay. Return type. Go. And parameter types. We'll do the parameter types. I'm also going to do a quick assert that none of these are null. I is 0, count is our count parameter types. Count I plus plus parameter type sub I. Oh, cool. Then we've got that. Then we need function calling convention, function calling convention. Is variadic is there. Interesting. Maybe the calling convention really only exists at the value level so far. That might make sense. Is variadic. Because the if you're passing around function types, you want to know what calling convention is specified with. So I should probably add the calling convention if it doesn't already exist. Let's go check. It does not. Well, I don't know. That 1, 2, 3, 4 should be all that's required here for a type. The kind and the function stuff. Okay, so we return the function type. Then in IRGen, back here, we can return type function type. There we go. In context. So to get the context, let's say YSC context. That's going to be type module context. Or actually, we want to also say module Laye. Still in the Laye space. Module. And then take that module into context, assert module null, assert context. Then we can pass the context, the return, the parameter types, the type function calling convention, and type function var args is equal to var args c. And that should give us a function. So that's good. This, though, is not enough. We also have to do I32 and no return, both of which we're very much going to want to cache. So we'll have to implement some way of knowing what these types are, which is going to be in the context. And here we've got these Laye types, which I'm going to move eventually, probably, maybe, somewhere, hopefully. But for right now, we're going to do the exact same thing and say for just straight up types from the IR, we want a handful of things. ISE type should exist. Poison should maybe exist. I don't have a type for it. but I'll leave it here as a unknown, doesn't need to exist. Type doesn't need to exist. Void does. Pointer does. No return does not. Bool does not, but we do want I1. Then we don't need an int uinter float right now. Pointer, void, and I1 are good. So we should then say like a dynamic array of int types to store all of our int types in for lookup purposes. I don't have a hash map, is my current issue. We might want to steal a hash map from somebody or implement our own very lightweight hash map or fake a hash map with just an array very soon. It's kind of what we're doing here. So we'll just do int types like this. And we're not going to worry about floats right now or anything else. We're just going to cache these handful of things. So let's go into context. We're going to want to do something. I'm going to see context. So I've already manually generated a bunch of predetermined Laye types. We're going to want to do a similar thing for the IR here. Problem one, I don't want to allow people to create types on their own. I don't want to duplicate the work of creating types. So the context should be requested to make types. But if the context has to create this type, I could lazily initialize them. That would solve my problem, I guess. So yeah, fuck it. Maybe we just lazy init. I'm not going to do it up here. We're going to lazy init. So in IR Gen, let's continue. If I build, first of all, if I build, where the heck am I? Function, I want to be IR Gen. That's where I want. Here. If I build, we have some errors to fix. Static declaration of type create follows non-static declaration. Oh, type create exists already. Okay, two things. This is not .s. This is not s. Then type create in IR. Type create. Where's the other declaration? Laye type create and Laye h. Oh, it's non-static here. I really don't want it to be in the public API. So type create is going to be out of the public API. Okay. It's an internal implementation detail. That means we don't need type destroy either to be in the public API because we're going to be destroying them internally. Type is not, do nothing, and then we'll get around to destroying types eventually. So then that should get us building again. Linker command exited. How to become a programmer like me? Do it a lot. There is no good advice aside from just program. I keep trying to come up with good things like, oh, go do this, go read this, go implement this. I don't know. But literally just find something to do and do it. There's so much information online that it is not hard to find. Just pick something, go read about it, and go do it. If you're going to read about it, it's useless if you don't do it right after or alongside it or whatever. Just, it's like anything else. You're not going to get good at basketball by reading how to do basketball or asking people how to get good at basketball. You go play basketball till you're good at basketball. Once you understand some fundamentals of basketball, you can learn more cool stuff. Like, oh, cool, I didn't know what a layup was. Now I have that in my repertoire, but I already know the basics of basketball. I've played basketball for 6 years or something. If you don't know what a layup is 6 years into basketball, it's not going to work. I mean, just go do it. It's as simple as that. It really is. I could tell you to go implement a UTF-8 parser in C. I've done that before. I like that if you want to learn specifically C, I guess. But I've been programming for more than half my life. You just got to do it. It's been my hobby since I was like 10. Just do it. Make your dreams come true. Shia LaBeouf. Linker command exited with exit code. Type is function is not implemented. Okay. Not. I thought value is function, but not type is function. Did I do type is function? I have all of these. Okay. Assert not equal to null. And return type is equal to type function. And then repeat all of these. So pointer needs to be type pointer. Void is type void. Array is type array. Function is type function. So block, then this is struct. I'm jumping back here. Float, integer, function. Okay. So that gets me that. We should be linking again. Okay. So now we need to no return. Cool. So let's add ISC type, ISC no return, which needs a context. All types are always in context here. So for function type, insert context not equal to null. Leak code only teaches you how to solve leak code problems. I have never solved a leak code problem myself, and I work in the financial institution industry. I have no formal education, zero. I went to high school in the United States and didn't take any real programming classes. Technically, I did, but I was smarter than the teacher by the time I took them. I have just been programming for so long, doing my own research, finding what I found to be fun, and I work in a well-paying financial job. I realize that I'm lucky to be able to do that, but it's not a requirement to do anything in particular. It may be worth it in your situation, but it was definitely not worth it in mine, right? So everybody's situation is different. If you think it will help you, maybe. Can't tell you definitively no, but I can't tell you definitively yes either. If context dot types no return void. So we don't, why did I make a no return type? We want a void type. Void. Not equal to null. If it is equal to null, we'll just do the implementation here. Then context types void is going to be void type. We'll create void type is IC type create, the static version in this context. Yeah, no problem. I wish I could be more helpful than that, but really you got to help yourself, and it always comes down to just do it. And there's absolutely nothing else special about void, so then we just learn this. Cool, now we have a void type. So in IR Gen, we can notice, hey, we didn't have no return. Void node type. No return And it just so happens, for our sake, that no return and void are identical in the IR semantics. We're just going to return ISE void type in context. So this should leave us with the I32 type that's left. So context type arena not equal to null. I need to initialize the type arena. ISE context. So we have a string arena here. Down here, we want a type arena. So instead of max and turned string size being the thing that we care about, we want to just say the arena block size should be like 1,000 times the size of a ISE type. So every block can contain at least 1,000 types. And ISE type is incomplete. That is correct. So then we'll just say, look, 1024 times 1024, and maybe we make it like twice that size, right? Well, usually I just do this. That should be more than enough to store types in. Then if we come down to destroy, we'll also grab arena destroy for the type arena, and then we'll array free context all types. We're not putting anything in there just yet, but we're about to. So since we're about to do that, let's go through do the arena second, because we want to actually clear this first. So within all here, ISE type destroy wants to be in the internal implementation. So I will actually say, look, void ISE type destroy ISE. So then in our IR, we have type destroy as static. I'm going to make it not static. It's part of our internal API, and this is not the greatest way to do it, but I'm going to do it anyway. So then in here, all the way at the bottom, we type destroy all types of I to make sure that it frees all of its contents, and we free stuff at the bottom there. So then back in here, we left off with type arena not existing. So let's clear, rebuild, do this again. And now we have unimplemented type kind in whatever from type int. Cool. And one thing I'm forgetting is type create needs to store itself in context all types so that we can iterate over it and destroy it. Boom, simple as. So final thing to do is case Laye node type int. Now we need to implement the int type. In our API, we want int type be in context with int bit width. We don't care if it's signed or not. The IR does not differentiate. It has signed instructions, not signed types. So let's come back into our IR. We're going to do something very similar to the void type here. So I'm just going to go ahead and create it. Let's say ISE type int type will be null. We want to go look it up. Let's say if bit width is equal to 0 or 1, then we're going to do a thing with this turn I1. It's going to be our special case type because it's our bool type. So I1 type, type int, and I1 type primitive bit width is 1. Then we just assert. We probably don't even need to make it special. I'm going to make it special because I want to. Assert bit greater than 0 and less than or equal to 65535 as our range of available bit widths. We should never need anything outside that range ever in a million years. So then down here, we're going to look up an int type. So for int64 ti 0 count is our count of context types int types, the ones that we've cached. This is our fancy hash map implementation by just doing it in an array. If we have an int type, so let's say Laye type int type. Let's say call it result type so that we can look at it later. If result type is null, we'll do something. So if int type is int, not null and it has a new type. If int type primitive bit width is equal to bit width, then return int type. So I don't need the result type either. We're just going to return it from here. So else, we're going to do this thing, right? Then r push context types, int types, int type, and int type. So then int type is a type int, and its bit width is bit width. Int types. Okay, that's a little bit more complicated than it really needs to be because we added this bit width is equal to 1 check. And the more I think about it, the more I'm like, nah, I don't think we need the additional I1 stored. It's not going to be so common that we're going to lose it. So if there is already a cached int type within our int types here, do some validation, make sure we didn't fuck up. If it has the same bit width as the bit width that we're requesting, then it's the type that we want, return it. If it's not, create a new one, add it to the array, and we're done. So there's our int type. So now here, we can just return Laye int type in context with bit width of type primitive. And now we should be able to compile if Laye type is int doesn't exist. It's probably type is integer if it exists at all. Yep. So rebuild context types int types of I. Yep. In direction. Thank you, compiler. Very cool. Cool. So then to do type destroy. Cool. So we've gone through and created all of our types, and it's trying to clean up after itself. So now we just need to go implement destroy, which is above us here. At the moment, we have nothing to destroy, we don't think. We might not ever have anything to destroy. We should go check. Our type has dynamic arrays inside of it, so we do want to go through and deallocate those arrays. Switch on type line. Default, don't do anything, we don't care. If it's a function, it's type function, we want to array free type function parameter types. We don't need to destroy any of the memory within the types because they're in an arena that will be cleared on its own, but we do want to destroy the functions because the functions are not in an arena. And then same thing for struct. In struct, we want to free members. And we do want to call destroy on any child type, though, because it could be any of these types we're checking. So before we free the array, we want to say for int64ti plus destroy this Laye. Then in struct, we're going to do the same thing for its members. So for every member, we destroy it. Then we want to destroy the return type. of a function. And the only other case is the element type of an array. So case YSC type array element type. Okay, so now we're destroying types. That should be all that's required. Does build. Okay, so we still have a leak I have to fix. It's in int type because we're not freeing the cache here. We want rFree context types int types. Clear. Destroy. Perfect. Still no memory leaks in the currently active code. And by the way, for release builds, we don't actually care about leaking memory. This is all behind the ndebug flag. So in a release build, we just don't free anything and let the operating system do it itself. This is just to validate that we're being nice programmers for debug builds, causing any unintended bugs on accident. So that means we have successfully generated top-level functions with types. We haven't done anything in the function body yet, and we haven't done anything with the function attributes, but we have generated main and exit as void functions with no body, and exit should be taking an I32. We don't have a way to print that yet. We'll have to write an IR printer, which we could do. We could do an IR printer. The other thing I want to do is implement something, need to be able to specify if this is imported or exported. We're not passing it its calling convention because that's coming from the function type. Right. Let's go take a look at the IRC. We'll open on this one as well. So in the type here, the function type itself has a calling convention. And if we look in the values, linkage and calling convention as well. So the IR function calling convention probably should be specified after the type, or we could get it from the type, I guess. Either way, we should also specify the linkage. So let's say function linkage, and we'll calculate that above. When I say linkage equals a thing. If, for now, I'm going to do it in if statements, and then we'll see if it's worth doing a whatever it's called, a ternary. So if our top level node linkage, which is a thing we have access to, well, okay, no, we do want to change this. If it is exported and then imported, but also exported. Okay, so we may have to do some tagging at the semantic level because I don't know if we actually have access to this. Let's start with step one. If function body is null, then we know it has to be either imported or re-exported. But at the IR level, I think all we care about is that it's imported. Let's say linkage, this one, function linkage equals, oh no, because, well, yes, but also no. It's imported regardless if there's no function body. It's just whether or not it's re-exported or not, which we don't know at the IR level. We would have to know at the SEMA level. So what I'm really looking for is if it's marked as exported and it doesn't have a body. So let's say if it has no body at all, if its current linkage is equal to, God, I really need a way to do this at SEMA. So much more information. If the linkage is link exported, then our linkage is going to become re-exported. And linkage, oh, it is an attribute. But if it's this, we're going to set this to internal by default. If we have an exported function with no body, it's re-exported. If we have a body and it's not, then it should just be imported. If not this, we're just going to default it to imported. I'm going to have to make this a touch more robust at the semantic phase, but for right now, we want it to at least kind of be correct in case I forget. If there is a body, then we want to do a similar check and just say, hey, it can't be imported because we're defining it. So worst case scenario, it's internal, which we already have. If it's exported, then it's just regular exported for now. This is where it's going to get more complicated, because if we've imported it from another module, the actual function declaration, so we're only looking at the top level nodes here, which is fine. We're not doing imports just yet. We should do imports, and that might fix our problem. I'll do that. This is for top level nodes that are within our module. For anything that's not in our module, we'll want to do the same thing, but I can't guarantee that this has been set. Too many arguments of function call, that's what it is. So for anything defined in this module, it's either re-exported, imported, exported, or internal. For anything that is not in this module, which we'll do later, we don't have right now, I'll go to do generate imports from other modules. When we're importing from another module, we'll never have internal. We'll only have re-exported or imported. And I think we'll have a better way to check that, so that's fine. We're not doing imports though right now, so we're just going to skip it. Next thing we need is Laye linkage. Linkage. Right, we're going to force every function to, every function needs its linkage specified. So linkage is in function linkage like this. We're going to grab this parameter, create function. That's not like C, create function linkage. Cool. Now we have linkage. Sure, it still builds. Cool. Great. So if we wanted to, we could go ahead and do an IR printer, which I might go ahead and say we do. Have an entry function for it already declared, Laye module print. We'll also want type print to string and value print to string. All three of these together are the bulk of the IR printer. So in IR, we'll do IR on this one, we're already in it. Put up in just in case I need. Let's get printing. I'm going to do it at the bottom. IR printer. So we want to print all of the functions in the module. We want to print types within that function, and we want to print values in the body. For right now, we definitely don't need to do anything with a value. So let's assert false and to-do. We're only doing function bodies for now. Go ahead and throw the to-do in here, but I'm planning to remove it very shortly. Let's just make sure we get to this point in the code and we're ready to go. So legacy module print will give us string. We can say string IR module string this. And then we can string destroy. Then we're done. We'll then want to basically do exactly what we did with the earlier module. Fprint IR module string, like this. So it's not going to do much. Let's, instead of asserting, let's set up our print context and get ready to go. So I'm going to grab the debug.c because I have this print context for Laye. We're going to copy it for Laye C. We want just the context. We can store use color, that's fine, because we can override it if we want. We don't need indents, but we do need output. It's a lot simpler here. So let's create a print context with context is module context with output is output. So we're going to grab the output string here and do some asserts. Module and module context. Then we can return output string like that, and we can do stuff to it. So the first thing I want to do is LCA string append. This is my string library. Append to print context output, just so I have something referenced instead of output string. We're going to append a comment. We're going to make semicolon be our comment in the IR, I think. Makes enough sense to me. Now, let's just print the module name so that we have something on the screen. And if we have colors, then we also want to make sure that we have some. So let's grab like color comment. Will be, I mean, we have bright black, right? Maybe. If I go to fancy bright black, that should be gray. So then we can say optionally mod s color of bright black would give us. We could then mod s again to color of reset. And instead of bright black, we want color comment. And why doesn't it like that? Use color is undefined. So first, let's do use color is module context color. And then I can move this into like static void ISE print or something, but I don't think I need that. So this is fine. And we'll just grab tool use color, print context use. Now my macros work. Woo! So then let's just print mod.stars, which is the module name. Laye C IR mod. Yes, needs a new line as well. So this will be stir expand from my string library module name. If we do this successfully, it doesn't like that IR module string. So I need a reference to it. We got nothing. It did do the new line. Oh, because bright black is the same fucking color as the background. You can't see it. Oh, there it is. There's our module. So we're just going to make it white for now. Instead of bright black, it'll be our reset color. So there's our IR module that we're going to start printing. We then want to print all of the functions. So let's just create a static void ISE function print. Well, if it's value, print to string. Printing that, no, because value we want to be the instruction value. So yeah, let's function print, which will take a LayeC print context, and it will take a LayeC value function. We'll put that up here. So then we will say one of two things. We want to function body blocks if the count of these is equal to 0, then we're going to print declare versus define. So let's actually just store this in a value in our variable. Bool is declare is this or something. if is, and we can actually just do a nice fancy thing here. So let's start with print context output. We want to do mod s, and this one I'll force onto multiple. We'll do that here. So mod s for declare. Do a color reset at the end. We want is declare there or define. Do something similar to LLVM. Space the name of the thing that we're declaring. So that's mod.start. Or stir and expand function. That's the name of the instruction. The function name. We get the name of the function. Then for now, we won't do any parameters. Another .s to say, let's actually expand this. So we'll do the opening parentheses first. Stop there. So that'll give us the name. Then after the parameters, we want mod s. We want mod s here as well as. Let's do a mod. Lots of mod. We want color keyword. Let's create color keyword. Color keyword will be red, or name will be green. So color keyword first. Then after, let's declare. Yeah, then before the name, it's color name, followed by the name. Then we want color limiter, which will also be white. Right? So that gives us the first half of a function. Then the second half needs color delimiter again. Then after color delimiter, we want thing and then reset. So then the thing that we want is, why is this not? Oh, we don't have use color defined. So color is print context use color. That should fix all those. Okay, so color delim, then is declare nothing or a colon to indicate that we're building something afterwards. And we could turn this into like C style brackets and blocks. I might do that. Like this. And then if not is declare, we'll just do a LCA string append format. I can type. And this. So no matter what we do, we want a new line there, and then we want this, but this needs to be this, and then this, and then probably another new line. And then this needs to be color delimiter, color set. Okay. Let's see if this gives us both. We're not calling it yet, so that's a problem. For every function in the module, for int64t equals 0 r count. We don't have a list of any of the functions. So let's go add a list of functions. And so let's count plus. Then we're going to Laye print function. Pass in the print context as well as module functions i. And then if I is greater than 0, I'm going to just append. So thing append format print context output a new line like that. So then we need to go into the module. So in IR, all the way at the top. module arena dynamic array functions. Okay, so then in module destroy, we need to array free module functions, and we need to, when we create a function, we need to array push module functions function. Clear, declare main, declare exit. Now this should be define if we were generating blocks, but we're not. So we don't have any additional information in here just yet, but we do have an IR that is starting to store function data. I haven't done type printing. I think I could do that pretty quickly. I don't know. Give me just a second. I've been, I think, pinged by work. I need to check that nobody's trying to access me at work. So if nobody needs me at work, then we can keep going probably. Getting pretty close to my work end day anyway. End of day for work, so I'm just going to assume that we're all good to go. Okay, cool. So yeah, let's go do type printing. We could put the type here, or you could put the type at the end. I think to be fancy, we'll put the type at the end. So that would mean the return type needs to go between here and here. So if we're doing that, then let's do it this way. So we've done this, just needs the color delimiter. Then this needs is declare the thing, else the thing, which still needs color delimiter. So the color delimiter again, because we're putting something in between it. Now we're resetting the color. So then between here and here, we need to do type printing. So let's start with this and say type print to string the type, which will be function return type. Well, type function return. We need to get the type out of the function first. Hi, how am I doing? I'm pretty good. How about you? Function assert type. While I'm here, we'll throw in the rest of the asserts that I didn't do. That's good. We're writing a compiler. Let me know if you have any questions. I like to ramble. Type is function type. Since it is, we can say Laye type return type. Return type will be function type function return type. And we also want the same thing for parameter types, which I'm not going to be inserting here. Parameter types would be parameter types. Cool. So then, now that we've got both, we'll start here. For int 64 ti, starting at 0, count as our count, parameter types, counts less than count, I plus. We're going to do some printing. This one is short enough. Just going to line again, which also makes it easier to copy. We want a delimiter and a comma. Then we want to same answer I gave the last guy that you weren't here for, just do it. Just do it. Just program. You want to learn more advanced C++ things, go try them and see what happens. Look up your errors, look up what you want to look how to do, just program. Right, like if I wanted to go learn how to, let's see, C++, what's a fun thing in C++? I don't know a whole lot about. Smart pointers. Let's go learn about C++ smart pointers. Not being facetious, not being anything, just straight up. Microsoft Learn might be a good spot to start. Stack Overflow maybe will link you to some good stuff. Just cool. Look it up. Go do it. Make small programs and make lots of them. I've been programming for entirely too long, about 17 years, maybe longer. I learned just by doing. I was excited to learn something. I looked it up. I tried it until I understood it. If I didn't understand it the first time, I tried it again. Unless you've got specific questions, that's all I've got. Just do it. You'll get there eventually. Don't give up. We want to type print to string the parameter types sub I. When I was 19, I knew only 2 languages really well. I knew Lua because I was a Roblox kid way back when, and I knew Java because I knew Java, basically. I just wanted to learn another language, and it was Java. But all of my free time was just those languages, so I got pretty good at it pretty quickly. I didn't fully understand what the hell I was doing in either of them. So, like, don't feel like it's fine. Yeah, just make applications. You say that you can't, that's fine if you know your limits, but try to push those limits. Just do it anyway. Right? I learned how to make compilers by just making compilers. I've never successfully finished one, quote unquote. I've gotten damn near close, and then I move on to something else, and then I come back to it later. But I just wrote compilers until I was comfortable doing it, and now it's second nature, right? Riding a bike, playing basketball, go play a sport. You got to do it until you know how to do it. No amount of book smarts will prepare you for actually writing the thing. There are so many little tips I could give you, but you wouldn't remember or know how to apply any of them. And I couldn't possibly anticipate anything you're doing in your project anyway. So, like, 90% of the tips I give you are going to go right over your head. Right? That's kind of the problem. It's just a huge field. And there's so many things you can do. You just need to do it until you figure out you can do it. So, from parameter types, the argument type Laye type is incompatible with whatever. Print to string Laye type pointer. Parameter types should be a pointer to pointer. It's a dynamic array of type. That fixes that. And then we want to print it to our int context output, and we want to use color. Cool. So then we want to do hello, Redstone tutorials. How you doing? No problem. I'll be doing this for a little bit longer. We want a %sign followed by the name of the parameter, which might just be an index. So we'll do LLD. That's good. And since it's a name, we want the color to be color name. And then we want I, parameter index. And by the time we get down here, we're doing delimiter colors and this colors. Yep, I'm on IR Gen right now as well. We're in the middle of printing out the IR so that we can do eyeball validation, my favorite validation. This is almost done even. Let me do, we've done this. Then if not, YSC type is void, return type. We can print the type. And if that's the case, then we'll include an arrow. Because arrows are fun. So this isn't going to print anything. It's going to say, hey, we haven't done the print type to string yet, but that's fine. Now we know we can implement it. It type not equal to null. Simple. And then the thing that we want to write to should also not be null. Then we can switch on type kind, and we'll start with case type pointer, even though we don't have it, because it's easy. We're just going to copy over some of this shit. We're going to print 2s keyword followed by pointer, which will be call keyword pointer, and then break. And at the very end of it, we can always print the reset. That's pointer. Then we have void. Yeah, we're doing that with this compiler too. I've got a bunch of small sub-projects that are just header files in here. So I needed a string library. I refactored some of my old string code into a single header file for string library support. So technically, I could upload this single header file as a small string library project if I wanted to. Easy. I did the same thing for my dynamic arrays. They're a very simple dynamic array implementation, less than 100 lines. It is all single file header implementation. This is its own separate project I could publish. Same thing for memory. I wrote my own memory allocator wrapper so that you can create your own custom allocators that use the same API, and I built an arena on top of that. This is all a single header file, so I can publish it whenever I want. It's less than 230 lines of code for a simple memory allocator. Like, just build some stuff until you find something you can turn into a project, I guess. I don't know. Just build stuff. I do not like C++. I've tried, not going back anytime soon. I am super happy in C. I love it. C++ just makes me upset. Okay, so type void. This is mod s by keyword void. And let's just go look at all of the types we have access to. I'll print them in the same order for shits and giggles. I just really don't like C++. It is a fine language that is not for me. So let's see, int mod ll mod d for primitive bit width. Okay, primitive bit width should be an int, which it is. But not for type integer. I'll do the same thing for float. Float. I don't really have suggestions for courses or books unless you have something very specific that you want to do. Like if you want to build a compiler, I highly recommend crafting interpreters. It's an interpreter, not a compiler, but the first half of a compiler and an interpreter are the same thing anyway, so that gets you on the right track. Crafting Interpreters is a very good, simple book that'll teach you how to do things in Java and C, so you can do a garbage collected language or a manually memory managed language, and pick your poison. Otherwise, I really don't know. Like I said, I just kind of learned by doing stuff and Googling. I don't have books. I don't have other things bookmarked. I looked for it, and I tried to teach myself as best I could. I'm not a good resource compiler. I don't have a channel in here, but I could add, if you wanted to join the Discord, which should be in the description, I could go ahead and add a... That's what I'm looking for. Add a text channel called resources. Boom. So if anybody wants to share resources that they like, we can share them in here. Cool, cool, cool. How do you call it when your compiler can also be an interpreter? Either, both. If it's a compiler, I'd probably just call it a compiler that, I mean, because like, terminology is stupid anyway. Let's be honest. Call it whatever you want. Say that it's both. Say that it's a compiler. Say that it's both. Ain't nothing to it, really. Array is going to be something. Print an array. We want to print to a string the type array element type. Then we want to print an opening delimiter. And then we're printing it to use color for my language called Laye. Currently, we are trying to compile or generate IR for this source code here. Laye is my take on a better C. I hate calling it a better C because the better C genre of languages is kind of out of hand, but I've been wanting to build something like this for years. Years and years and years, and I've technically failed at doing so. I've made a lot of good little compilers, but they've never been completely finished. So we're working on getting this thing in a state that I can finish it sometime in the next couple weeks. We're doing IR Gen right now. The goal for Laye is it's my take on C with really good C interrupt. So Zig if I didn't build it 5 years ago and make it Zig. Yeah, LCC was Lens's compiler. It's probably still going. He's still working on it. I've stopped working on it. And I've taken what I've learned from LCC to make this the best version of a compiler I've ever written. I'm really proud of it so far. And like I said, hopefully in the next couple of days, basically, we'll be compiling to LLVM and executing code again. And from there, it'll just be a few more weeks to get the basic features all implemented in the parser and semantic analysis, in the semantic analysis and parser phases. Currently, I've implemented just enough parsing and semantic analysis to make this a valid program, but not much else. There's not much else you can do. So I'm going straight back to code generation so that I've got a lot of things built up and I don't have to do giant refactors in the future. And I'll hopefully be streaming more of the parsing and the semantic analysis and the code gen as they come. So you'll see the whole compiler be built kind of in parallel. Yeah, I don't have stream archives for doing the parser or the semantic analysis pass because I got excited and did them off camera. But you should be able to see as I build them out in the future, I'll stream them. Okay, what was I looking at? We need to implement array type. Yeah, he's been working on the object file backend or the assembly backend for a while. I wanted to hijack his assembly backend, but now that I'm just working on my own compiler, probably learn from it. He's got good compilers. Learn from his compilers. Go watch his original series. The C++ series is kind of a mess. It's probably not that useful to you for a learning resource. It's a good watch, but it's not that good of a learning resource, aside from a couple episodes where we literally had Saraid give lectures. Those lectures are very educational. I can recommend those. Saraid is a good educator. But yeah, the C++ series is not a good learning on writing a compiler in C++ as much as it is just learning how to write C++ high-level new features stuff. So print type to string gives us that. Then we want it to have for every length. What lengths do we have? Count of type array length. So in Laye, we're supporting multi-dimensional arrays, but those are just going to get collapsed down to a single length. So what we're going to do here then is copy this shit out, grab colored lim, and then we want mod LLD with a color of like constant. So this is, yep, and color constant. That. And constants can be, fuck it, yellow. Or I think we did blue before, so we'll say constant is blue. I'm going to try to be a little consistent. That gives us an array type. We don't have an array type now. So, I mean, this is all the types we have. I can implement a function type in a second. I shouldn't need it. Switch type kind. Yeah, it's missing function and struct, but that's fine. So int main is void, int exit. Cool. Now, if we made them non-void, I don't think Sema checks return types. So I could make this like an int, and it wouldn't complain in some Sema yet. Parse type. Oh, it doesn't hit int. So we'll hit i32 because it knows what an i32 is. Right, so then there, main returns i32. It's not technically semantically valid anymore because that part of Sema has not been implemented, but it's there. So boom, we are generating some textual IR that is mostly correct. We haven't included calling convention in the IR yet. Probably ping people on Discord when you're live. The announcements has a publish feature, so I don't know how this announcements channel works. But if I come over here and say test, for example, I can share it with my followers and publish. So every time I go live, I ping in the announcements channel and hit publish, but I don't have a role to ping, right? So if this is not a great way of doing it in Discord, then I can switch to a ping system, sure. But I don't know. I do ping. I ping with the publish feature. New things and resources. Look at that. That's a good source. Sure. Publish, create a thread, edit, add reaction. I don't know what publish does then. Yeah, so I guess if you're following this channel, then it's fine. I can also just go create a, I don't want to ping everyone. So do I have an at ping at stream? I don't think I have a role for this. So stream note, I do have a stream notifications role, but nobody has it. And I don't have a system to like give people roles without just asking. So I could just say, hey, stream notifications role if you want it. Moderator. Moderators should all have access, and I think I'm a moderator technically. I'm an admin. There. Cool. So let's see. I think we can very easily print the calling convention as well. We'll just have to turn it into a string, which I don't think we have right now. Keyword. We still have access to the keyword color here, so declare. So we'll grab the calling convention to C string. If I do this, then I'm inclined to say that this would return like the all caps version. So really, I should just turn this into like, I'll just make it this static. Which on the calling convention base Laye CC. It might not have a calling convention, which I guess it should. Default should never really exist, I guess. I can add an assert for that. If it's C, then return CCC. If it's ISCC, return ISCC. Default, assert, plus, and unsupported, unimplemented. Cool. Good enough for me. So now I don't override the default calling convention in my IR gen yet. So here, IR function type generates the calling convention. The calling convention is handled down here. The default calling convention then will be done here. I do have that warning enabled. Yep. Almost 1,000 subscribers. Nice. I do have that enabled. Where was I just at? Not in here. We were in here. Yeah. I have it enabled. Really what I should do is case default, because the default calling convention should be overridden by either Sema or IRGen, depending on the language. So then we can say this goes at the bottom, and then this we just say default calling convention is not valid after during within. Right. That's really what I mean. So we'll go add. My friend who has no idea what's going on is going to be the most confused about all these. Oh, you no, he's not. He's just joining in. Yeah, I just don't know how. Okay, so that's really what we wanted. This is going to print the calling convention, which is mandatory. So calling convention. Okay, I typoed something in IRGen. And it's telling me, and I was distracted. Calling convention. Spell wrong. So then, if calling convention is equal to CC, alt CC, then really it should be, well, okay, at this point, the calling convention should be set in Sema. So I'm just going to throw here that calling convention should never be default CC, and that's then in Sema, when we're doing function type creation and stuff, when we're analyzing a function, I don't remember what it's called, so I just kind of generate dependencies, solve top level nodes, dependency order for each dependency, off top level types. So at top level type time, if function, we could come over here then and say if node decal function, it does not have the calling convention. It's going to have a declared type, which is maybe a system I should change slightly, but I've done it already. So let's see. So when we analyze the declared type, does this need to handle calling convention? If we analyze a function type, when we're analyzing a function type, I guess in here, if function has a calling convention, so if is equal to default CC, then it's ISC CC, right? Then that should never hit that. What else are we missing? Type function and type struct, that's fine, we're not doing those just yet. Then calling convention is not valid with default calling convention, not valid within the IR. Okay. Well, that's good. How are we getting there? Got this. So when we create the IR function, let's go put the same assert in function type. ISD function type calling convention. assert calling convention does not equal the default CC, and that'll tell us where we're creating it. Okay, then if I run this, we should hit, I assume, that breakpoint. No, we don't. Just coming straight from the function calling convention. So when we're creating the function, is it not inheriting it from the type? When I create, this returns a function type, which should not have default CC. If I create the function type, it's assigning the calling convention, which is not default CC. So when we create the function, does it have a calling convention that I'm not? It does. So the calling convention needs to come from function type, function calling. Okay, so declare Laye CC main and declare CCC. So technically, if we want to be semantically correct, this would also be foreign. And really, this foreign attribute should be marked automatically by Sema for the main function. But for now, we're not doing that. So this is the most semantically correct thing. Cool. We are halfway to IR. Halfway there. Halfway there. Let me... A lot of changes. I have not committed in like a couple days. Oops. And I don't care that much. I'll just fuck it. I think I'm gonna have to log back in. No, it's still cached my stuff. That's good. Cool. All of the repositories should be linked. Yeah, it's mirrored in 4 different locations, so pick your poison if you want to look at the source code. I imagine most of you are going to be wanting to look at it on GitHub, so GitHub is provided. It is great. I don't have in the README just yet. We can do an update real quick. Edit support. Let's go grab that. That is, well, https://github.com/Laye yes code, if I'm correct. Boom. If you have Visual Studio Code and you want the editor support for it, it's here. It's great. Zedrich is the primary contributor. I fix a handful of things that I'm like, oh, I never mentioned that. He updates it. Cool. We're on last week's 1.7. I don't know if I'm actually up to date. I'll figure it out later. But that'll give you syntax highlighting for the thing. Can I preview? Do I have Markdown previewing? Did I do I did the link correctly. Cool. It just needs a period. Bunk. I have accidentally closed my YouTube stream. That's good. Stream is still live, but I'm not checking it. I'm not looking at fucking chat. There you go. Chat is back. So let's commit that separately. Git and git. Yep. Update readme with editor support link. Beautiful. Beautiful, 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 beautiful. So. I guess we're on to actually generating IR in IR Gen. So we've generated the function itself. We need to do function bodies. I'm not storing this anywhere that I can access it. I might do that at the syntax node level because I don't have hash tables and I don't want to write one right now. So I come down here to Laye node, wherever it's implemented, Laye node, here, we can add some IR types here. So that might be the easiest thing to do. If I said ISC type, IR type, and now ISC value. I probably don't need the IR type. I just need the IR value, and I can get the type out of the value. So that's fine. I'm now doing IR gen. All right. Why does my brain not like that word? During IR gen. Anyway, so what I would do here then, assert that function is equal to null, and top level node IR value is IR function. Boom. Easy peasy. So then what we want to do is do another good old-fashioned iterate over everything. I'm going to copy the whole thing and delete what I don't want. And what I don't want is everything here. If it's a function, we want to say Laye c value function equals top whatever. Search our function is not null. Type. Search that it is a function. Type is function? No. Value is function. Value is function. And then we want to create a function builder. Well, I say and then. We really only need one function. So ISC builder is builder create in context. We don't have a context, but we have a module with a context. Hello? I didn't give it a name. That's fine. Module context should exist. We haven't pulled the context out itself. So builder, pointer to builder. Then all the way at the end, builder destroy builder. We're done with the builder. Great. So let's, at the end of every function, we're going to say builder reset. And then we want to position builder position at end of a new block. So we want the entry point block. So let's generate a block. If function, well, if up level node function body is null, then we're going to do stuff and probably nothing. Then we want to say we don't have a way to make a new block, so we need to have a block append. So like ISC builder. We create a block. So function append block. Take our function, append a block. ISC value entry block. So it needs a name. Call it strconst. Oh, svconst entry. Good enough for me. So we can position at the end of the entry block. Right? So then we'll have to implement that. Then we need to write the function. And to do that, we want static void question mark static. If it's an expression, we want to return the Laye value. And everything is technically an expression, we'll return either null or, I think we'll return null, or a void expression or something. Yeah, everything being expression kind of confuses me now because I return a value. I guess if it's a What do I return for a block? If I have a compound expression that doesn't return anything, its type is void, then we return null? I don't have a unit value. I guess null is the only thing that makes sense. That's fine. I can return null from Laye generate expression node. Generate node, sure. We don't have an IR gen context. Our context is our builder, and then the context it contains. So I would say builder. A node. That's what we want to implement way the hell somewhere. Boom. Assert builder is not null. Let's assert node. Not null. Switch node kind. Fault can be else. Node kind this, node kind to string, node kind. Give me something to work with. I plan to make it self-hosted, but not by turning it into Laye, by turning it into a C compiler as well. I would love to write some self-hosted stuff in Laye, and I might do some implementation in the future in Laye, but my current goal is you can get yourself a Laye compiler with the source code and a C compiler. So at least some version of the Laye compiler needs to be C only. When we get to a point where the language is like kind of stable, then we can turn this C version into a sectioned off bootstrap compiler if we really wanted to start self-hosting in a way that's not backwards compatible with a C compiler. But yeah, if it's going to be self-hosted anytime soon, it'll be by implementing a C compiler, not turning the compiler into a Laye self-hosted compiler, right? That's the idea. If you can just git clone or wget the source code and then run the build tool, which is written in C, which only just executes Clang on itself, then great. That's the hope. That's the plan. That's the maybe we'll get there eventually. Okay, so let's see. The first thing that we want to do is at least try to generate a call instruction. I say that, we really want to do the compound expression. So let's start with compound. We'll work our way down the tree. Case node compound. We need to return something. I don't know what we're going to return. If we break, maybe we just return null at the bottom. But do I want to be explicit about returning null everywhere? Maybe. Is that not explicit? Technically, no. We'll do this, and then we can assert thoughts unreachable. So, node compound children. For every child, do a thing. For our not plus null. Why are you mad? Just taking forever? N, yeah, cool. So then we just generate node builder child. And in this case, we do just want to like explicitly say, look, it doesn't matter. Get rid of it. Where do you get the count variable from? I can't actually see stupid chat messages behind this. This is kind of dumb. Let me... This little fucking heart thing blocks the edge of the chat window, so I'm assuming it just says count with nothing after it. There's only a handful of characters missing. The count variable just comes from... I'm doing two variable initializations in the for loop here. Count is coming from this macro that gets the array length of this dynamic array. So we're declaring I and count of type I64. Cool. So let me generate the node here. Well, that's compound. Easy as technically. Not really, because we need to know if this is an expression or not. We don't know if this is an expression or not. So let me regenerate it then. Copy. No limit. That's what we want. Never expire, no limit. All right, new. Copy. Edit. Thank you for pointing that out. I'll have to go update that on all of the old videos later. There's a tab called Introduction. You set this up, you can add questions, which give roles. Okay. What year was I born? No. Don't say it. Maybe you get to be. Do you want to be an admin or a moderator since you know how to do stuff? Add an answer. What question? I'll look at that after stream. But that looks very helpful, thank you. So here's the thing. Compound expression is an expression. But we're not using it as an expression anywhere yet. I don't technically support it. So, to do. This can be an expression. So it really should return stuff, even if discarded. The last, we wanted it to be yield. Yeah. It's going to be a phi hell. And we can actually just figure that out later. I don't actually know what perms any of these things have. At the very least, you can be a moderator, and we'll see what perms that has. What is an add? Moderator can display roles. You can mention roles, perms. You can create invites and nicknames and kick and ban and timeout and stuff and use you can application commands, that's normal. You can do all this stuff. You can mute and deafen people, that's cool. You don't have any admin permissions though. So maybe we can make you an admin and then you'd have admin permissions. Wow. Dangerous permission to grant. I could do it. I could maybe do it. We'll think about it. You're at least a moderator. We'll give you halfway permissions, and if I need your help so much that I don't want to do it myself, we'll make you an admin. Okay, so yeah, we'll figure out yielding from a thing. What I'm referring to here is if I had like int a yield 10 is how you do that. I'm not going to allow, I don't think, just doing like Rust style this, where you don't put a semicolon or it's assumed the last one is a return or something, like we're tracking the expression context, and if it's an expression, this is returned. And I think we're just going to say yield. And then if not all code paths yield a value, it's invalid at sema, right? That's what I think Laye is going to do. That's roughly what I'm trying to process here, but I don't think is actually valid. So the reason that I'm allowing return null is because I don't know what fucking int a equals return does, because return has type no return, which has no value. So I could create just a unit value for no return, but it has to exist. So I could make it a global value, like a constant, like a that always exists, like nil would be one of those things. So I could make an IR value representing the lack of a value, besides just nil, because nil is the lack of a value, but it's a value. This is the lack of a value, but it's never a value. I could create the void type and the void value, I guess. Make void a constant. But for right now, we're just going to say return null. It's easy enough to grep within the function when I want to change my mind. So we've generated a compound node. We've implicitly discarded all of the results there. We're not using them. And then we generate an expression. Okay. So we don't need to store anything in any nodes at the moment, but when we start doing variable declarations, well, no, because if they're going in the node, then the lookup will find them. So that's fine. Okay. So the next is case Laye node call. The call needs to do a couple of things. For right now, it will return the result of the call, which we'll have to generate in a second. So we want Laye C value call E would be generate node for the node call E. This one definitely can't be null because we have to call it. Then we need to generate all the arguments. So dynamic array IC value, arguments, argument values. Where did it all go? Count is our count of node all find arguments. I less than count I plus plus. We want to array push. Do I have an array reserve? I do have an array reserve. So I could reserve into argument values. And I don't have to push. And then I can just say argument values sub I equals generate node node call argument sub I in the builder. And then we can assert that these are not null as well. Well, I mean, again, for now, they are not null. Technically, I could call exit with return. That would be technically invalid. But if no return is implicitly convertible to any type, then maybe not. So for right now, we're only allowing these. We don't have the concept of a no value, so I'm just asserting that it's not the case. But yeah, I really should just make it. Hold on, let me go look at my instructions. Instructions. So we have stolen the high level, some of the fucking LCC instructions, but I can come over here and we can add a new one. We do poison, but that's not good. We want concept of nothing. Or I guess we could just say that these have their own value. They always have a value, so we just return the return value. Right, I don't need a specific value, but this doesn't have a value associated with it. We don't have an instruction for a compound node. We'll be generating a phi, though. So if it isn't in an expression context, then we don't have any phi's to generate because there's no yields. So in the case of no yields, compound still needs its own value, which should be, I guess, void. So we have phi's, load, stores. Nil will be of type something. Nil is special. It's an integer value on a thing, or it's a null pointer. So if we had void as a value, it would have to be of type void. So I need a instruction value integer constant. Let's say IR void right above poison. I don't think that conflicts with anything. So then we'll just return void. So down here, the IR, We want to build void, I guess. We don't need to build void, it's a void constant. I can call it unit instead of void, that maybe be slightly more useful. It is a constant. I'm just thinking about the public API here, is why I'm confusing myself. Not terribly complicated what I'm doing here. So if I wanted to say, look, I don't need to build void, but I want like Laye void value. I don't want to create it. I don't want to say in context because everything's in context. So I'd see like, let's go ahead and grab the context here. Context is IC builder. Context builder. We want to make sure we've got access to that somewhere. So that needs to be the public API. Sure. Builder, context, builder. Builder. Go ahead. Implement that somewhere in IR. So builder. Here. Okay, easy enough. So then IC void in context easy. I'm just gonna call it void constant because it makes it fucking make sense to me. Then I just have to go create a void constant function. So here we've created a function. We're not building it, so constants can go here. IC value, void constant, IC context. Right, and then we can store constant values up here in our context. So we've got types. Let's just do values and say void value. And we'll worry about other constants later. So then if I'm implementing void constant, I come right after create function right here. Context is not equal to null. Return context values void. So if it's null, then YSC value void value is value create in context. Ooh, gotta be in a module, which I don't like. We don't have the capability of creating a value outside a module. Unless it's null, but then I need it to be a value in context. Let me go update my public API or my internal API here. Say create in context and only in context. And it's got everything else. Now we want just context does not equal to null. It's going into we have to delete it. So let's just say I'll say allocate context allocator. The size of the value. Value should not be null. Module is null. Context needs to now be explicitly set. But now I've got places where like value module is expected not to be null because my API is changing, so that's going to cause issues. So value create in context. Context do a thing. We'll do the thing in just a second because I also need this to say context. Context like that. Okay, so now void needs a location. It's just not going to have. No location here. IR void constant. Doesn't make sense, but I'm rolling with it. Eternal, unless you have a better idea for what to call this void constant unit or something for my newly expression-based language that I've never designed an expression-based language for. The type will be IC type void in context, which needs to exist. We'll do that in a second. And the name is sv empty. Then assert void value equal to null, and assign this equal to void value, and then again, because I am entirely too extra, this is not equal to null. The type of void. I am currently just fucking creating the concept of a void value, because a void expression, like, it shouldn't return anything. There shouldn't be any instruction associated with it. But I don't want to just return null from the function. Yeah. So I've made it a touch easier on my eyes and called it a void constant, but it is still just void. A value of type void. Okay, so then I need to go into IR. Void type. Is it implemented? Yeah, I've implemented void type. So why did that look weird? Why is he? Because I called it type void. Void type. There we go. That's what's implemented. Okay, so now, IR gen. Void constant in context exists. Cool. So now we're not returning null. We want to never return null ever. So, and this doesn't count because it's no return. It's just there because I'm spooked. Okay, so now we can assert that things don't return null. Since I'm generating children, I can do ISE value. Let's assert null. Ensure that I never ever return null ever. Okay. So now we have arguments. We have a callee. Now we need to build a call. This is where we're going to start actually building things with our builder. So ISE value, ISE builder, I'm going to call it build call. ISE build call in builder. We want a ISE value callee. We need the type of the callee, right? ISE value type. Callee type, maybe, because opaque types, right? And then dynamic array, ISE value arguments. And the callee type would have the calling convention information in it, so maybe we don't need to pass that in, and we can pull it out of the type if it's a callable type. So that should be all we need to do to build a type. So what we're missing here then is ISE type callee. And the reason that matters is if we're calling through a function pointer, pointers are opaque. So we don't have function type information. So, it's just a function, it's fine. Where do I get the callee type if not from the callee code? Because I can convert this. So we can be like, look, equals, we're going to say ISE type, callee type is callee. Well, I need to get the type out of the value because my API is opaque. So ISE value get type callee. Then we could be like, if ISE type is pointer or something, because we're calling through a pointer, callee type, then right. Maybe that makes sense. Maybe it does not make sense. I do not know. I do not know, says I. But for right now, we're just going to assume that it's this. So up here we have values. We have type, value is whatever. Let's say ISE type, ISE value, get type, ISE value. Fat fingers all over the place. assert value not equal to null, and for shits and giggles that its type is not. When value type. Easy. Then. Type is pointer already exists, so then we're passing in the callee type. So let's return build call, builder, callee type, and argument. So now we have to go implement build call in IR, insert with name. Right after insert with name, we're building, we're going to assert a fuck ton of shit because again, I'm anal. Assert that builder exists and has a context. Assert that callee is not equal to null. Assert that callee type not equal to null. The values within will assert separately. I think I have a nice for loop assert I can copy paste, so I don't have to type a for loop. I don't care. So 0 counts arguments I plus assert arguments of I. No, cool. Then we just want to say legacy value call is, I guess we just allocate it. I don't have anything fancy to do other than to allocate it. So you create, we need a module with it. Does builder have a module? It just has a context and a function. And the function that we're inserting in it exists. The block that we're inserting in exists. And the function should have a module associated with it. Yeah. So then we can create the value in the function module. Bonk, 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 like that. Cool. Location needs to be provided. So let's say legacy location. Add that to our requirement. Location. Kind is IR call. Type is the result of the call. We can only call functions right now. So we're going to grab the callee type and say legacy type result type is call function return type. We're going to assert callee type kind type function. Grab the result type, and then the name. We got to give it a name. Another thing with the API. String view. Every single thing has a name. And that's name, which will be interned for us, question mark. String view name will be interned. So again, call not equal to null. Result type not equal to null. Return the call. Arguments is arguments. Call. Ooh, wait. Leave is calling. Then we have calling convention, callee type. We'll get the calling convention. I'll probably have to have a couple of different functions for building calls that handle this differently, but the calling convention is function callee type function calling convention. And what do we have left? Arguments callee collected is tail call is false. We'll build a tail call separately. Okay, so then that is our call instruction. Only thing left to do is builder insert, builder, and call. Cool. I think that's all I need for that. So in IRGen, node location, and then just SV empty for anything we don't have a name. That is our call. So the only thing left to do is case Laye. It's a evaluated constant. Are we at? name ref needs to be done for the callee, and evaluated constant needs to be done for it. So name ref should reference a declaration. That declaration should have a value and return that. Then the question is what kind of value it is that we're looking up. So case node name ref. Assert that node name ref referenced declaration is not equal to null. We have a declaration somewhere. The easiest thing to do is to return the declaration's IR value, right? So we could also then assert this not equal to null, which will probably make sense because this will return the function. If it's referencing a local variable declaration, it will be an alloc instruction. So this will be of type pointer. So in case it's an R value, then it would, or an L value, then it would be converted to an R value. So I guess what we'd want to do is if this name ref is, but that would be handled by the L value to R value conversion. We would do a load if necessary. So I don't think this has to do anything else. I think if we had L value to R value conversion, right, it would do the cast. That would be fine. And once it's done the cast, that would be something we implement in here. So this should be good. Then we just need case Laye node lit int, which needs to return an integer constant. So Laye value, Laye int constant, Laye context. And then we want a constant and the type. So we want Laye type, and int64t value. And for right now, I'm not going to cache this. I'm just going to generate it. I'm getting actually kind of close to the time I need to be done. So we're just going to generate it. We might not get to printing this stuff today, but if we can at least get it to not error, that would be great. Void constant, Laye void constant right here. So int constant is going to be very similar, except we're not going to do the cache check. So we're going to check that context and type. Null. We're also going to verify that Laye type is integer. Then we can do Laye value. Value is value create in context. Context location. We didn't give it a location, but we could give it a location. So let's give it a location. Laye location. Right, we have access to a location. Not that important, but we do have it. Location. Then we want the kind is IR int constant. The type is type, and the name is just going to be SV. Return the int value after assert int value null. Int value. I don't think I've implemented the integer constant part of value. So in here, parameter index, allocated type, you just say int64 value. So I can just go back to wherever we were here and say is value, return the int value, and there's our constant. So then go back to wherever we were in IRGen, and we can say return Laye int constant in context at node location of type node. Let me convert Laye type. Int type is convert type node type. Assert that int type is not null, and its type is int. Use type, and the value would be Oh, it's not node lit int. That's right. We want node evaluated constant. So then I'm just going to say that the type is not null. I don't care what type it is. Till we say if node evaluated constant dot result dot kind is equal to eval int, then we're going to generate the int constant, which will have node evaluated constant result int value as its value, and it will be of type. And then here we can assert that Laye type is int of the type, and then plus assert plus and unsupported implemented constant. Null for my brain. My brain likes null. So that gives us the evaluated constant. We don't evaluate any of its children because they resulted in the constant. We have a call, a name ref, and a compound. Do we, one, have errors? And if we have errors, we do. Are they easy to fix? Append block. We didn't do append block. And expected semicolon after return statement. IR Gen 202. Okay, so then we need to implement function append block. So ISE value, ISE function, append block, ISE function, string view block. Okay, so then module create function. Assert function, now we put the null. Need access to the function's module has the arena or the context? Module. It's not Laye function. Laye value. All values here. Values all the way down. Module is not null and the context is not null in this case, but module should have the arena. Yes. Then we have the block is arena push. Module function, module arena. And I guess for creating a block, it doesn't actually matter. I don't need this. I need to say create value create with the module, so it doesn't matter if we've got anything here. From the module, we need a location. I'm going to say Laye location empty because blocks are kind of arbitrary. IR block type would be Laye void type in context. We don't care, and then name, whatever name we got. Then function module assert block null and block, but we need to our push function block function blocks the block, and this block needs its name set to name, so this needs to be sv empty. For that, instructions and parent function. Parent function is this, instructions is null by default. So that appends us a block and returns it. This name needs to be context intern string view function module function. Does it have a context? It does, right? Name. And for shits and giggles, function would equal to function module. Should be this. Okay, so now we can append a block. Does this build, other than the warning that we plan to fix? Yes. So then out. It's all right. We have a leak. It tried to print something though, so it knows we have blocks. I just can't print the blocks yet, and we've just got one more leak to fix. So I've been kind of rushing through the end there. I'm about to go to dinner, so I'm not going to have time to finish printing this, but We do have it generating blocks. It's not emitting any heinous errors. It may not be correct yet. We can't quite look at it and see, but hey, it's there. So either I fix this printing off stream, and it's about to be Christmas, so I don't know when I'm going to stream next. I got a busy weekend, and then I got work next week, but we will probably stream again sometime in the next week or so. I might have some of this fixed up and ready to go. We might be generating LLVMIR, I don't know, but keep up with the Git repositories and or the development channel in the Discord. I do post stuff that I do off stream all the time. It's every now and then. Maybe we create a compiler driver called fuck, I don't know. Go learn stuff. The invite has been updated. You can join. Keep updated. I'm going to go get ready for dinner. Thank you guys for tuning in. I'll see you eventually, I guess.